Welcome back to the Explainer. Today, we're exploring a new paradigm that completely flips how we interact with microcontrollers. Honestly, it kind of feels like science fiction. If you've ever had a brilliant idea for a physical gadget, but then hit an absolute brick wall when it came time to actually write the C++ code, well, this explainer is definitely for you. We're talking about Luna Lab Edition and its core game-changing concept, AI-Native Firmware. Okay, let's dive right into this. I want you to imagine completely bypassing the frustrating 70-year-old ritual of embedded development, just skipping it entirely. It brings up this really fascinating question. What if you could just talk to your hardware? Like, literally just speak to it. No complex tool chains, no compilers, no screaming at your computer screen at 2 a.m. because of a single missing semicolon. You just tell the hardware what you want it to do in plain, everyday English, and it figures out the rest. To really get why this is a big deal, let's look at the contrast. In the traditional embedded development workflow, things move at an absolute snail's pace. You have to learn complex C or C++ syntax, you wrestle with weird wiring quirks, and iterating takes minutes, sometimes hours. You write the code, compile it, flash it. Actually, scratch that. First, you spend an hour fixing your environment. Then you flash it, watch it fail, and you're stuck deciphering cryptic error messages. But the Luna Lab Edition approach? It flips the script entirely. You simply describe your idea in your own words. The AI iterates in seconds, not minutes. And the absolute best part? If there's a bug, you aren't the one parsing a stack trace. The AI reads the results and fixes the code itself. Now, what's really interesting here is the core paradigm shift. We're talking about AI-native firmware. This is hardware built from the ground up to be programmed by an AI, not a human. It completely throws away the traditional integrated development environment and the compiler. Gone. This hardware is specifically designed to converse with an AI. So instead of you having to learn the machine's language, the machine uses AI to understand yours. So how does this actually play out in reality? Well, it's an incredibly simple 4-step workflow. Step 1, flash it once. You just put the firmware on the board one single time and you're done. Step 2, connect to your AI. Step 3, say what you want. You could literally just type, "Hey, turn on the LED when the button is pressed." And step 4, watch it happen. The AI writes the code, pushes it to the board, runs it live, checks the results, and, autonomously fixes any bugs if that LED didn't actually turn on. It's this unbroken, continuous loop of creation, and you're just the one directing the show. Let's demystify the magic a bit here, because there is some really brilliant technology under the hood making all of this possible. Luna Lab Edition relies on MCP. That stands for the Model Context Protocol. It's an open standard that essentially turns your ESP32 board into a mini server, equipped with a built-in Lua scripting engine. And this acts as the bridge between your physical hardware and AI clients, like Claude, for instance. Now, why Lua? Well, because it's incredibly lightweight and exceptionally easy for an AI to parse and generate on the fly. So your logic lives on the board as a Lua script that the AI can just rewrite in real time over the network. You don't have to keep reflashing the core firmware. You're just having the AI inject new instructions straight into the engine. Once you grasp that architecture, the sheer potential of this workflow becomes so obvious. First off, there is zero barrier to entry. Literally zero. A complete beginner can build working hardware behavior in their very first minute. Second, you have that self-testing and self-fixing loop, where the AI runs the code and reads the outcome autonomously. Third, it's one firmware for infinite programs. Because of those dynamic Lua scripts, the compiled firmware never actually needs to change. Next, it's an open protocol, meaning absolutely no platform lock-in. It works with Claude today and any MCP-compatible AI tomorrow. And finally, you get full hardware access. The AI can directly ping your GPIO pins, Wi-Fi, Bluetooth, file systems, the whole shebang, all without you writing a single line of C++. So, the crucial point is that this completely shatters the wall between having an idea and holding a working prototype. I mean, look at who this empowers. Makers and hobbyists who want to build way faster than they can learn complex syntaxes. Complete beginners and kids who are usually totally locked out of embedded development. Educators who can finally teach the core concepts of sensors and automation without getting completely bogged down in syntax errors. Artists building interactive installations who think in terms of behavior, not code. And even professional engineers. Sometimes you just want to prototype a concept in seconds instead of grinding through a full, tedious build cycle, right? Let's move on and see how this builds into an actual physical product line. Luna Lab Edition currently features a family of 3 main models. You've got the Lab 32, which runs on the standard ESP32 chip, giving you the essentials: GPIO, Wi-Fi, and the Lua engine. Then there's the Lab S3, running on the ESP32S3. That one is full-featured and adds Bluetooth Low Energy 5 to the mix. And finally, the Lab node, which is a lightweight, BLE-only companion node for multi-device setups. And the true beauty of this lineup, they all speak the exact same MCP protocol and use the exact same Lewis scripting model. You just pick the chip that fits your project without having to relearn a totally different way of working. Now, just a really quick point of clarification. You might have heard the name Luna Observatory floating around and wondered how it relates to Luna Lab Edition. Basically, Luna Observatory is a sibling project. It's specifically designed as a telescope control edition for astronomy. But the Luna Lab Edition we're looking at today, it contains absolutely no astronomy-specific code. It is a completely clean, general-purpose platform meant for literally any electronics or IoT project you can dream up. If you're as fascinated by this as I am, you're going to love how shockingly easy it is to get started. You do not need a build toolchain at all. You just download the ready-to-flash binaries straight from their releases page. You flash it to your board using a standard tool, like ESP-Tool. Connect the board to your local Wi-Fi, add its address to your MCP client, like the Cloud Desktop app, and then you just start talking. You're literally up and running in minutes, completely bypassing hours of traditional setup headaches. Let's briefly touch on the licensing structure for Luna Lab Edition. It's built on the shoulders of some fantastic MIT open-source components, most notably the Lua 5.1 scripting language, along with some other third-party libraries. However, it is important to note that the Luna Lab Edition firmware itself is distributed as a free-to-use closed-source binary. So what does that mean for you? Well, you can freely use, copy, and redistribute the binary firmware for your projects. You can even design and sell compatible hardware boards. But the core source code for the firmware itself isn't publicly available. It's a pragmatic approach, keeping the tool free and accessible while protecting the creator's intellectual property. And this brilliantly illustrates the sheer empowerment of this tool. The creator's own philosophy just perfectly sums it up. You don't write code, you have a conversation, and your hardware does the rest. That is the absolute core takeaway here. The old answer to making hardware work was to force yourself to learn its language. The new answer is to let an AI speak it for you and simply tell it what you want. Which leads us directly to a question I want to leave you with today. If the barrier to coding is completely gone, if you literally never have to compile another line of C++ again to make a physical gadget work, what will you tell your hardware to build today? The possibilities are pretty much infinite, and I really hope this explainer has inspired you to grab an ESP32 board and give AI-Native Firmware a try for yourself. Get out there, start that conversation with your hardware, and I'll catch you in the next explainer.